Good morning, students. Today we are going to discuss the continuation of third module, that is Introduction to DIF FFT Algorithm. Good morning, students. Today we are going to discuss about Module 2, that is the continuation of fast Fourier transform. As already we have discussed this DIT, that is decimation in time, radix to FFT algorithm. Now, today I am going to discuss about decimation in frequency, radix to FFT algorithm. In decimation in frequency algorithm, the frequency domain sequence x of k is decimated, whereas in DIT, the time domain sequence x of n is decimated. That is the difference between in DIF and DIT. DIF means decimation in frequency, DIT means decimation in time. And in this decimation in frequency algorithm, the n point sequence is converted to two numbers of n by 2 point sequences. Then each n by 2 point sequences is converted to two numbers of n by 4 point sequences. This process is continued until we get n by 2 numbers of 2 point sequences. Now we will see the steps involved in 8-point radix to DIF FFT algorithm. Now the first point is the number of input samples should be expressed as n equal to 2 to the power m, where this m is nothing but number of stages. M is nothing but number of stages. Here we know that n is equal to 8, that is 8-point DFT. So your n is equal to 2 power 3. So how many stages we will have means 3 stages we will have. 3 stages we will have, and this is nothing but radix. So already I have told that this is a radix to DIF FFT algorithm. This 2 is nothing but radix. And here how many stages are there means 3 stages. That is number of stages is m, that is equal to 3, whereas your first stage will be 2 power 3, that is your first stage, that is n point DIF FFT, and your second stage is 2 power 2, that is 2 4-point DFT, and your third stage is 2 power 1, you will have 4 2-point DFT. Now your input sequence will be in the normal order. Your input sequence will be in the normal order, and each stage consists of n by 2 butterflies. For example, in stage 1, it is represented by n is equal to 2 power 3. Hence there are 4 butterfly diagrams. Hence there are 4 butterflies. And the next one is the number of complex multiplication is given by n by 2 log base to n. And the number of complex addition is given by n log base to n. Whereas the twiddle factor or the base factor, the base factor will be given by omega nk is equal to e power minus j 2 pi k divided by n. In the first stage, these are the twiddle factors we are going to multiply with your inputs. That is omega 80, omega 81, omega 82 and omega 83. In the second stage, these are the twiddle factors that we are going to multiply the output of the first stage. That is nothing but the input of this second stage. That is omega 40, omega 41. And whereas in the third stage, you will multiply the input with this twiddle factor omega to 0. That is nothing but that value will be is equal to 1. All the 3 stages twiddle factor values will be given here. And the last one is nothing but we are going to compute the output. How we are going to compute the output is the output of radix to DIF FFT algorithm will be in the bit reversed order. So what we have to do? We have to arrange in the normal order. So that now we will go for the problem. We will understand the computation of DIF FFT algorithm. Before that, we will see the basic butterfly diagram of DIF FFT algorithm. Okay, this is the basic butterfly diagram of DIF FFT algorithm. Now, in this basic butterfly diagram of the 8-point DIF FFT algorithm, how to compute this operations. The butterfly diagram, that is the butterfly computation, involves the following operations. So in basic butterfly diagram, in each computations, two complex numbers, that is A and B, are to be considered. And the sum of these two complex numbers is computed, which forms a new complex number A. Then subtract the complex number B from A to get A minus B. The difference term A minus B is multiplied with the base factor or twiddle factor to form a new complex number. Okay. Now this is nothing but your basic butterfly diagram of your DIF FFT algorithm. Whereas A and B, these both are inputs. Using this DIF FFT radix 2 algorithm, we are going to compute a new value A, capital A, that is nothing but equal to A plus B. And the another new value B, that is equal to A minus B omega nk. So this is about your basic butterfly diagram. And the difference between your this DIT and DIF is, in DIT, in the basic butterfly diagram of DIT, A is equal to A plus B omega n nk, whereas in B is equal to A minus B omega n nk. So that is the difference between DIT and DIF FFT algorithm. Now this is nothing but your signal flow diagram of your DIT FFT algorithm. So here we are having three stages, that is stage 1 is nothing but n point DFT, and stage 2 is nothing but n by 2 point DFT, and stage 3 is nothing but n by 4 point DFT. In stage 1, that is nothing but your n point DFT, here in DIT, we need to take bit reversal and then we are going to apply the input for the butterfly diagram. But in DIF, you are not going to take the bit reversal. Whatever the sequence given, in that order only we are going to take. This x of 0 to x of 7. And then the twiddle factor will be multiplied here. In DIT, the twiddle factor will be multiplied here. But in DIF, the twiddle factor will be multiplied here, and already I have shown in the basic butterfly diagram. The twiddle factor should be multiplied here. And then the output of the first stage will be taken and it is considered as the input for the n by 2 point DFT. Same thing here also, here we are having 4 point DFT. The twiddle factor should be multiplied here, and then the output of the second stage will be taken and it is taken as the input for the third stage of your n by 4 point DFT. And finally your output will be in the bit reversal order. Here you need to write the output should be in the normal order. This is nothing but your overall butterfly diagram of your signal flow graph of your DIF FFT algorithm. And one more important concept you should know, that is nothing but in place computation. In place computation is very, very important in the butterfly diagram. What is meant by in place computation is nothing but, if you observe that the basic butterfly diagram, we are having two values, that is A and B, and we are going to compute the new values capital A and capital B with the help of these values A and B. Once A and B are computed, there is no need to store the value of A and B, the small a and small b. The same memory location can be used to store the new values A and B in the place of small a and small b. That is nothing but, here we are going to store the value of A in the place of small a, and we are going to store the value of capital B in the place of small b. This is nothing but your in place computation. So thank you students. Tomorrow we will discuss the problems which is related to DIF FFT algorithm. Tomorrow I will start the problems on DIF FFT algorithm. Thank you.